Hi everyone, welcome back to... Today we're diving into a super exciting topic that powers everything around us, energy. Can you guess what it is? That's right, energy. Energy is what makes things happen. It's the ability to do work, making things move or change. Energy comes in many forms and can transform, but it cannot be created or destroyed. This is the Section 2, Forms of Energy. Get ready to be amazed, energy explorers, because energy comes in many awesome forms. Each form has its own superpower. Get ready to zoom into the world of the energy of motion. Anything that moves possesses this incredible energy. The faster something moves, the more kinetic energy it has. Mass also plays a role. Imagine a bowling ball and a tennis ball rolling side by side. The heavier bowling ball has more kinetic energy. Kinetic energy is all around us, powering countless activities. When you ride a bike, your pedaling generates kinetic energy. Hydroelectric dams use the kinetic energy of flowing water to turn turbines, generating electricity. From the smallest particles to the largest celestial bodies, kinetic energy shapes our universe. Now let's shift gears to potential energy. It's stored energy, like a coiled spring or a book on a high shelf. Gravitational potential energy depends on an object's height above the ground. Potential energy can be transferred, like a stretched slingshot ready to launch a projectile. When potential energy is released, it transforms into other forms, often kinetic energy. Think of a roller coaster at the top of a hill. As it plunges, its potential energy converts to kinetic energy. Potential energy is all around us, playing a vital role in countless natural phenomena. The heat is on exploring thermal energy. Thermal energy is the energy of moving particles within an object. The hotter an object, the faster its particles move, and the more thermal energy it has. Temperature measures thermal energy, and we use thermometers to gauge it. Thermal energy can be transferred in three ways: conduction, convection, and radiation. Conduction is direct contact, like cooking pancakes on a griddle. Convection involves fluid movement, and radiation transfers heat through electromagnetic waves. Let's delve into chemical energy stored within molecular bonds. Food contains chemical energy fueling our bodies. Fuels like gasoline release chemical energy through combustion, powering cars and generating electricity. Batteries store chemical energy, powering our devices through chemical reactions. Electrifying our world. Electrical energy is the energy of moving electric charges. It powers our devices and homes, generated by converting other forms of energy. Electrical energy can be transmitted over long distances, bringing power to our lives. Sound energy vibrations that reach our ears. Sound energy is produced by vibrations traveling through a media. These sound waves reach our ears, allowing us to hear. The pitch and loudness of sound are determined by the frequency and amplitude of the sound waves. Light energy illuminating our world. Light is electromagnetic radiation we can see. The sun is our primary source of natural light, but we also have artificial sources. Light can be reflected, refracted, and absorbed, allowing us to see and understand our world. Section 4. Harnessing the power of light and sound. We use light for illumination and data transmission. Solar panels convert sunlight into electricity, and lasers have various applications. Sound waves are used for communication, music, and medical imaging, showcasing their versatility. Section 1. Energy on the move. Hold on tight, energy explorers, because we're about to uncover the amazing ways that energy is constantly on the move, transferring from one object to another. It's like a game of energy tag, where energy is always being passed along, creating a chain reaction of excitement. Remember how we talked about kinetic energy, the energy of motion? Well, kinetic energy is a master of transfer. When a moving object collides with another object, some of its kinetic energy can be transferred to that second object, setting it in motion. Imagine playing a game of bowling. As the bowling ball hurtles down the lane, it carries kinetic energy. When it strikes the pins, some of that kinetic energy is transferred to the pins, sending them scattering. But energy transfer isn't just about collisions, it can also happen through sound, light, and heat. When you strum a guitar string, the vibrating string transfers energy to the surrounding air molecules, creating sound waves that travel to your ears. When you turn on a lamp, electrical energy is transformed into light energy, illuminating the room. And when you heat a pot of soup on the stove, thermal energy is transferred from the burner to the pot and then to the soup, warming it up. Section 2. Transforming energy from one form to another. Get ready for a shape-shifting adventure as we explore the remarkable ways that energy can transform from one form to another. It's like energy has a secret identity, changing its appearance while always conserving its total amount. Remember the law of conservation of energy? It states that energy cannot be created or destroyed, only transformed from one form to another. This fundamental law governs all energy transformations in the universe, from the smallest atom to the largest star. Let's look at some examples. When you turn on a light bulb, electrical energy is transformed into light energy and thermal energy. The light bulb emits light, allowing us to see, but it also gets hot because some of the electrical energy is converted into heat. Think about a roller coaster. As it climbs the first hill, it gains potential energy. At the top of the hill, it has maximum potential energy and minimum kinetic energy. As it plunges down the hill, its potential energy is converted into kinetic energy, sending it racing along the track. Energy transformations are happening all around us, all the time. From the food we eat to the cars we drive, energy is constantly changing forms, powering our world in countless ways. Now that we've explored the amazing ways that energy can transfer and transform, let's zoom in on how these processes play out in our daily lives. From the moment we wake up to the time we go to sleep, energy transformations are constantly at work, powering our every move. Think about your morning routine. When you toast a slice of bread, you're using electrical energy to power the toaster, which then transforms that energy into thermal energy to brown the bread. The chemical energy stored in the bread is then released when you eat it, providing your body with energy to start the day. When you ride a bike, you're transforming chemical energy from the food you eat into mechanical energy to pedal the bike. As you pedal, your bike's tires grip the road, converting your mechanical energy into kinetic energy, propelling you forward. Even when you're relaxing and watching television, energy transformations are taking place. Electrical energy powers the television, transforming it into light and sound energy, bringing your favorite shows to life. From the simplest task to the most complex technologies, energy transformations are the driving force behind our modern world. Understanding these processes empowers us to make informed decisions about energy use, conservation, and the development of sustainable energy sources for the future. We've been on an incredible journey, exploring the fascinating world of energy. But have you ever stopped to wonder where all this energy comes from? How do we power our homes, fuel our cars, and keep the lights on in our cities? Get ready to dig deeper as we uncover the sources of energy that make our modern world go round. Some sources are renewable, meaning they can be replenished naturally. Others are non-renewable, existing in limited quantities and taking a long time to form. We can keep using renewable sources because they are constantly replenished. Understanding the difference is crucial for making informed energy decisions. Let's delve into non-renewable energy sources. These energy heavyweights have powered our world for generations, but they're finite. Fossil fuels, coal, oil, and natural gas, formed over millions of years from ancient plants and animals. Heat and pressure transformed these remains into the fuels we use today. We extract fossil fuels through mining and drilling. These fuels generate electricity and power vehicles. But burning fossil fuels releases pollutants, contributing to climate change. Nuclear energy comes from splitting uranium atoms. Nuclear plants generate a lot of energy but produce radioactive waste. This waste must be stored carefully to prevent contamination. We've learned about all the amazing ways energy powers our world, from the food we eat to the lights in our homes. But here's the thing, using too much energy, especially from non-renewable sources like fossil fuels, can harm our planet. That's why it's super important to become energy conservation superheroes. Think of it like this, energy is like money in your piggy bank. If you spend it all at once, you won't have any left for later. It's the same with energy. If we use up all the non-renewable energy sources too quickly, we won't have any left for future generations. And remember, those sources take a really long time to form. Burning fossil fuels releases harmful pollutants into the air, like invisible villains causing trouble. These pollutants can cause respiratory problems, acid rain, and even contribute to climate change, making our planet warmer than it should be. That's like leaving the refrigerator door open. It wastes energy and makes things messy. But don't worry, energy conservation superheroes, we have the power to make a difference. By using energy wisely and finding ways to conserve it, we can protect our planet, save money, and ensure a brighter future for everyone. Now that we know why energy conservation is so important, let's put on our superhero capes and discover some simple yet powerful ways to become energy-saving champions. Be a light switch superhero. Turn off lights when you leave a room. Next, become an unplugged patrol member. Unplug devices when not in use. Look for the Energy Star label when replacing old appliances or light bulbs. Be a transportation transformer. Walk, bike, or carpool whenever possible. Remember, small actions can make a big difference in energy conservation. Wow! Energy explorers, we've been on an incredible adventure today. We've journeyed through the dynamic world of energy, uncovering its many forms, its remarkable ability to transfer and transform, and its vital role in our lives. We've learned about kinetic energy, the energy of motion that propels us forward, and potential energy, the stored energy waiting to be unleashed. We've explored thermal energy, the warmth that keeps us cozy, and chemical energy, the hidden power within the food we eat and the fuels we burn. And who could forget about electrical energy, the lifeblood of our modern world, sound energy, the vibrations that bring music to our ears, and light energy, the illumination that allows us to see the world in all its glory. But our journey doesn't end there. We've also learned about the importance of energy conservation, understanding that energy is a precious resource that we need to use wisely. By making smart choices in our daily lives, turning off lights, unplugging devices, and embracing alternative modes of transportation, we can all become energy-saving superheroes, protecting our planet for future generations. As we move towards a brighter energy future, remember that knowledge is power. The more we understand about energy, the better equipped we are to make informed decisions that benefit both ourselves and the planet. So keep exploring, keep asking questions, and keep shining your light on the wonders of energy. Thanks for joining me on this electrifying adventure. Until next time, stay curious.